This is Charles. Today we're going to talk about how to run a simulation on both the impeller and diffuser and how to make the simulation converge. So in this simulation, I didn't start from Vistasticity. I started straight from BladeGen. Because I imported the BladeGen file from a previous simulation. And then you would go into TurboGrid. Um, So what we want is we probably don't want any warnings or errors from TurboGrid. Um, so there are some values you can play with to make TurboGrid happy. So mesh quality is a very, very important aspect of simulation. However, I don't believe our team currently have enough knowledge on how to create a good mesh or even to tell what is a good mesh. So here we're just gonna follow the TurboGrid tutorial and just make the internal check of TurboGrid happy. For example, here the boundary layer control didn't give us errors. And if we go to mesh statistics, there are some okay-ish values, but there is no bad values, so they're good. So what did I do to play with to get this result? So I played with the global size factor. Um, You can increase the factor so that you will get a finer mesh. Normally, they helps. However, you don't want to increase this mesh too much. It will make the you don't want to increase this factor too much. It will make the boundary layer control unhappy. I'm guessing it's some sort of numerical or connectivity issues. There are this kind of rates factors you can play with. Another thing you can do is you can explicitly control how fine the mesh in different regions be. For example, the inlet region, the flow is slow. There is no wall. So you can like use a fine coarser mesh so that more mesh can be distributed down there. I picked the 20 value. I think it probably can be a little bit more coarse. Okay, so say now you have a good enough mesh file. Now let's go to CFX. So previously, I think in the tutorial we mentioned that we use the fluid flow turbomachinery system instead of just the vanilla CFX. Here I followed the CFX tutorial, kind of did the vanilla version of CFX. It did miss out some of the nice plot template that turbomachinery system would give you, but I feel I have a better control in terms of the simulation. So it's the pros and cons. So in order to make it converge, I feel that I find the upwind is more likely to converge compared to high resolution. Also, turbulence, I find first order is more likely to converge than high resolution. And for the timescale control, I started with auto timescale, um, and then moved to physical timescale for it to converge. I think for the value I'm using here, it's 1 over omega uh, in radians per second. I was looking through some online forums. They are recommending like from 1 above omega to 10 above omega. You can try all the values. Okay, so that's the solver control part. There are other parts that you should pay attention to. For example, the make sure all the surfaces are correct, especially this interface. Believe CFX Pre is just the turbo mode is not happy with this interface. It always gives me the wrong name in the setup. Uh, so make sure you double check all your boundary conditions make sense. Also, I found that for the materials for each domain, the ideal gas is much more likely to converge compared to air at 25C. Um, Probably because in this simulation, the outlet temperature, it's going to be like 400 Kelvin, very far from 25C. So I would recommend use air ideal gas. Also, make sure you are taking into account your reference pressure. Here, I used 1 atmosphere pressure. You can use 0. Just make sure that for example, inlet condition, make sure you are using something that is reasonable. Um, because I used reference pressure at 1 atmosphere, so the relative pressure here I just set it to 0. Okay, so that's stuff about this simulation. Yes, one more thing. So for the time scale, I found online that they say if your result fluctuates, increasing timescale might help. So make sure like you try different timescales if your simulation didn't converge. Okay, so that's about everything here in the CFX pre. Now let's look at the over steps that I had. Probably take a while for it to load. It's kind of a big mesh. The impeller has about 1.7 million elements, and the diffuser have about like 50, uh, sorry, half a million elements in there. So well, it takes a while to load. Okay, now let's look at what I have here. So as you can see, all the residuals are now below um, 10 to the minus 5, and the Pmass is even lower. That is good. And if you look at our efficiency, now it's converged at polytropic at 78.3% and isentropic at 74%. That's a reasonable value. So what did I do to get this? So you see this big fluctuations. That's because I was using higher high resolution turbulence model plus the automatic time scale in the conservative mode. And then here I switched to the um, physical time scale. I tried between like 1 over omega to 10 over omega. It kind of converged a little bit better. And then I changed the turbulence model back to first order, and then it converges. I don't believe our current um, team have enough knowledge to tell the, say, trustworthiness of a simulation, like the accuracy difference between a higher resolution and the first order. So I would say it's more important for us at this moment to have a converged simulation. Okay, so say now you have a converged solution. Um, we can now go to results because now we're using the vanilla CFX. We didn't use turbo machinery CFX. We have less plot that's created by the template. So here I want to show you some tricks. For example, we want to plot a blade to blade, sorry, meridional plot. You just go to the turbo tab and do the thing you want and apply, and then you get a meridional view. If you want blade to blade, it's the same thing. Pick, for example, velocity, the range, the contour you want, and you will get something. Also for 3D view, if you want to do, for example, the inlet, I want to see the blade, and you get the 3D surface. I think we can probably, yeah. So, for example, if you want to plot the pressure on the blade so that maybe you can compare to the imported pressure into the FEA during the simulation of fluid-solid interaction, you can also like manually create a contour. For example, I created here contour or domain. I want to plot impeller blade, inlet, diffuser blade, and diffuser outlet, and I want to know the pressure. And if I plot and go to the correct view, I get the pressure on my plot. And you might be curious, like why there is negative pressure, because here it is showing the relative pressure. Our reference pressure is at 1 atmosphere, so you want to add 101,325 Pascal on this. Okay, so that's all about how to run the vanilla version of CFX and get a converged result. Happy simulation.